In these slides, we want to see experimentally what happens when we put a magnet or some source of magnetic field and we move the magnet or source of magnetic field towards or away from a loop of wire that's just hanging in space that has no battery connected to it. It's just a plain loop of wire, and the loop of wire is connected to an ammeter. So we have a circuit. This loop makes a kind of a circuit, but it has no source of EMF. There's nothing that can make a current go through it on its own. So we're just trying to put an ammeter here to see, is there going to be a current induced in it or not? So in this case, we have a permanent magnet, and the magnet is moving upwards. So the magnet has a north pole in the up direction and the south pole down, and it makes a magnetic field pointing upwards like this. And so when you move the magnet upwards through this loop, towards the loop, the observation is that we detect a current in this direction. And the current in this direction means that when the current goes like this, it goes into the red feed of the ammeter, then the current will be reading a positive value. So this is an experimental observation. Okay, if we do this experiment, so this experiment, you have a loop of wire and it has a current in it, and a current that you control. You put it on some particular value and you keep it constant. Keep the current in this loop constant, but then move the whole coil upwards. So this coil is making a magnetic field, and you move it upwards, and you find that there's an induced current in this loop in the same direction as before. Or you could keep this coil fixed in space, not moving upwards, but you can change the current in the loop and make it get bigger with time. So it can make this current in this direction and getting larger with time. And you'll still notice that in this loop, you'll get an induced current in this direction. Same effect. Okay, now if we change things slightly, let's take the permanent magnet, but we move it away. Instead of moving it towards this loop, we'll move it away. What you'll notice is that the current will be reversed in direction. And reversed in direction, so it'll be minus on the ammeter instead of a plus. It'll be going in the opposite direction. We could do the same thing, a similar thing, by getting this coil of wire and keep a constant current in it, but move this coil, all of it, downwards. So you'll notice also that the induced current will be in this opposite direction that we just mentioned just now. Another experimental observation, if you put this coil and you keep it fixed in space, but you reduce the current in the coil, make it get less with time. Also, you'll notice that there's an induced current in this direction. Okay, and what if you put the magnet, a permanent magnet, but you keep it fixed in space, you don't move it at all? You'll observe that there's no current at all induced in this coil. Nothing. And you can also get no current if you keep this coil having a current in it, and the current is constant and it's not moving. So it's not moving up or down. So there is a current here, it's making a magnetic field, but the current is constant and it's not moving upward or downward the coil. You'll notice that there's no current induced in this loop.